Lesson 14, Stem and Leaf Plot. A stem and leaf plot incorporates the data values themselves into the construction of the graph. The digits making up the data values are separated. This separation in the digits is illustrated in the graph with a vertical line. The digits to the left of the separation line are called the stems. The stems are listed vertically in numerical order. The digits to the right of the separation line are called the leaves. The leaves are listed horizontally in numerical order. Each and every data value is utilized in the construction of the stem and leaf plot. In order to distinguish one data value from the next, a noticeable space is displayed between consecutive leaf values. Here is an illustration of a generic stem and leaf plot. A descriptive title appears at the top. The vertical line represents the separation of the digits in the data values. The stems are listed vertically in numerical order, and the leaves are listed horizontally in numerical order, with a noticeable space displayed between consecutive leaf values to distinguish one data value from the next. Each of the leaf values displayed in a stem and leaf plot corresponds to a specific data value. In this stem and leaf plot, the first leaf, which is 5, is displayed immediately across from the stem value of 30. Together, the 30 stem and the 5 leaf correspond to an actual data value of 305. 305 is the minimum data value in this sample. The last leaf value in this stem and leaf plot, the 1, is drawn directly across from the stem value of 35. And together, the 35 stem value with the 1 leaf value corresponds to the actual data value of 351. 351 was the maximum data value in this sample. All the other data values appear in between in the stem and leaf plot. For instance, the leaf value of 8 is drawn in this case directly across from the stem value of 32. And the stem value of 32, together with its leaf value of 8, corresponds to the actual data value of 328 in this sample. Like a histogram, a stem and leaf plot reveals the distribution of the data. But when you look at the stem and leaf plot, to see the histogram in it, you need to look at it from its side. And then imagine that instead of the data values stacked on each other, in place you had the rectangles that the histogram has. The stem and leaf plot actually displays the same type of information as the histogram does. One advantage to the stem and leaf plot is the data values themselves are retained in the graph. Unlike the histogram loses the actual data values, and in their place are the bars in the bar graph. So all we know is in the first bar that there were 2 data values that appear somewhere between 300 and 309. We don't know what the actual data values are. But in the stem and leaf plot, where the actual data values are used to construct the plot, you can see here that those data values were actually 305 and 308. One disadvantage to the stem and leaf plot is the construction of the graph becomes more and more problematic as the sample size increases. Since each and every data value is plotted in the stem and leaf plot, the bigger the sample size becomes, the more involved the creation of the stem and leaf plot becomes. There are several factors to consider when constructing a stem and leaf plot. One factor is the location of the separation point within the data value digits. This location must be in the same position for each and every data value in the graph. For instance, if we had data values of 87.65 and 123.4, there are several choices to place the location of the separation point. One such separation point could be made between the hundreds and the tenths place value position. If this were to occur, the 87.65 has no hundreds value in its hundredths place value. In that case, when you plot it in the stem and leaf plot, you must include the leading zero. There are other choices for the location of the separation point. We could use the separation point between the tenths and the ones place value. Or you can use the separation point between the ones and the tenths place values. We also have a choice to make the separation point between the tenths and the hundredths place value. In this case, the value of 123.4 has no digit in the hundredths place value. And if this value was plotted in the stem and leaf plot, the trailing zero would have to be included. Another factor to consider is the grouping of potential leaf values. For instance, the 10 potential leaf values, that is, all the individual digits 0 through 9, can be grouped together evenly in 4 different arrangements. That's because 10 can be factored in 4 different ways, either as 1 times 10, 2 times 5, 5 times 2, or 10 times 1. So, one grouping could be of 10 leaf values across from one stem. In this case, each stem value is listed one time, and next to that one stem value, any of the 10 leaf digits 0 through 9 can be displayed. Another option is to have a group of 5 leaf values across from 2 stems. In this case, each stem value is repeated 2 times. And then the first time the stem value is listed, the digits 0 through 4 are displayed. The second time the leaf value is listed, the digits 5 through 9 are displayed. Another option is a group of 2 leaf values across from 5 stems. Here, each stem value is listed 5 times, and then the leaf values are displayed next to each stem in such a manner where 0 and 1 are displayed across the first listing, 2 and 3s are displayed next to the second listing, 4s and 5s next to the third listing, 6 and 7s across the fourth one, and finally 8 and 9 amongst the fifth one. We can also group 1 leaf value across from 10 stems. Here, each stem value is repeated 10 times, and then each of the 10 leaf digits are listed one at a time across from each of these 10 stem values. An appropriate choice for the location of the separation point and the grouping arrangement of potential leaf values produces an informative stem and leaf plot that clearly reveals the distribution of the data. So careful consideration must be given to all the options in order to make the decision that will produce the best stem and leaf plot. You see, too few stem values can conceal crucial details. Too many can dilute the essential elements of the distribution.